Hey there, 6th grade. In this next video, we're going to talk about special relationships amongst lines, specifically parallel and perpendicular lines. So when line segments or rays intersect, they form angles. And we talked a little bit about angles in the last video you watched. If the angles formed by two intersecting lines are equal to 90 degrees, or right angles, then we call those lines perpendicular lines. So lines that intersect at 90-degree angles are perpendicular lines. So an example of that might be this line and this line. Okay, notice these two lines here, as close as I can by freehand, intersect at an angle that is 90 degrees, and so these lines we would call perpendicular. We also have the possibility of lines in the same plane that do not intersect at all. And when lines are in the same plane and they do not intersect at all, we call those parallel lines. So an example of parallel lines would be a line like this, and then another line in the same plane that does not intersect that line. Okay, you can think about railroad tracks. Okay, railroad tracks have two bars for the trains to run on, and those bars have to be parallel to each other, otherwise eventually one bar will run into the other one. So parallel lines are in the same plane and do not intersect. And there's a third type of relationship amongst lines that you may not be familiar with, but those are called skew lines. Skew lines do not intersect, but they're not parallel lines, and the reason they're not parallel is because they lie in different planes. The easiest way to explain skew lines is just to take a look at this visual diagram down here below. So we have sort of a 3D image below. You can imagine this as being a box or something of the sort. And imagine that I have one edge of the box, let's say this upper right edge here, and imagine this is a line on one edge of the box, and this line lies along this top plane here, and then we have a second line on this edge of the box, and this line lies along a different plane. Okay, it lies along this front-facing plane here. So this pink line and this blue line here, these two edges of the box, these lines are not going to intersect, but they're not parallel because they're not on the same plane. Okay, this blue line does not lie along the top of the box, and the pink line doesn't lie along the front of the box. So because they're on two different planes, we call them skew lines, not parallel lines. Okay, so in these examples 1 through 3, we're going to tell whether the lines appear to be parallel, perpendicular, or skew. So let's go ahead and start with number 1. Number 1 asks us to compare line AB and line AC. So line AB is this line that I had just highlighted a moment ago. And then line AC would be this line here. Okay, so by appearance, we can tell these lines are intersecting because they both contain the point A, so they're definitely not parallel, and they can't be skew if they're intersecting either. Remember, parallel and skew lines, neither of those intersect. They appear to intersect at a right angle, so the best option for these lines would be perpendicular lines. Okay, number 2, we have line CE, which is this line here, and then we have line BD, which is this bottom line here. These lines are not intersecting, and this is another example of two lines that are not in the same plane. Okay, these two lines, you can think of this green line as being above this blue line here. They're not going to intersect, but they're not in the same plane, so we call them skew lines. Okay, number 3, we have line AC, which I've already highlighted in purple up here, and then line BD, which is highlighted in blue. So line AC and line BD don't intersect, but notice they're both a part of plane ABD. Okay, they both lie on this front face of this box. Okay, so because they're both on the same plane, we would call those parallel lines. All right, moving on, we're going to talk about another type of angle, and that's called a vertical angle. Vertical angles are the opposite angles formed by two intersecting lines. And something special about vertical angles is they always have the same measure, and so vertical angles are congruent. Okay, and you can see here in this picture an example of some vertical angles. So notice we have two lines that are intersecting, and these lines are just intersecting at some random angle. They're not right angles. Okay, so they're not perpendicular lines, but we have two pairs of vertical angles in this picture. Okay, this angle here and this angle here are both vertical angles, and so that means that these two angles that I've highlighted in blue are congruent. They have the same angle measure, and that's what these tick marks here represent, these single tick marks. And then we also have another pair of vertical angles on the opposite, on the other adjacent to these angles, next to. This angle here is congruent to this angle here. So angles that are opposite or directly across from each other, again, we call those vertical angles, and they have the same angle measure. They are congruent. Okay, on the back side, another vocabulary word we're going to look at, that's what's called a transversal. A transversal is a line that intersects two or more other lines. So in this diagram to the right, you see that we have three lines total. We have two lines that appear parallel here that are horizontal, and then we have a third line that is intersecting both of those parallel lines. That third line is what's called a transversal, okay, because it intersects two or more lines at the same time. When a transversal intersects two lines, 8 angles are formed, and you can see that in this picture. Okay, we have angles 1, 2, 3, 4, 5, 6, 7, and 8 here formed by this intersection. When those two lines are parallel to each other, so this top and bottom one appear to be parallel, all of the acute angles formed are congruent, and all of the obtuse angles formed are congruent. So you'll notice here I've color-coded these angles to show you that the acute angles are angle 1, angle 4, angle 5, and angle 8. All of these angles here are congruent. They have the same angle measure. And notice angles 1 and 4 are vertical angles. They're opposite angles directly across from each other. Angles 5 and 8 are also vertical angles. Okay, but all 4 of these angles are congruent. And the same is true of angles 2, 3, 6, and 7. Okay, those angles are all congruent to each other. The obtuse and the acute angles are therefore supplementary as well. So if I took angle 1's measure and added it to angle 2, I would get 180 degrees. If I took angles 2's measure and added it to angle 4, I would get 180 degrees. Okay, so a lot of information here in this paragraph that's important to understand. The fact that the red angles are all congruent to each other, the blue angles are all congruent to each other, and one blue and one red angle would give you 180 degrees. So we're going to apply that now to these last few examples here. I've told you in the directions that line N, which is this vertical line, is parallel to line P. That's what this symbol here means in these directions. Okay, this symbol here means is parallel to. So line N is parallel to line P, and based on that information, we're going to find the measure of each angle. Notice we have a transversal here, this line here, that's intersecting both of these lines N and P, and therefore we're getting 8 angles again. Okay, so number 4 asks us to find the measure of angle 6. So first of all, let's find angle 6. Angle 6 is right here. So we're going to use what we learned in this paragraph above to find the measure of angle 6. Well, notice that angle 6 has a vertical angle of 55 degrees. Okay, angle 6's vertical angle straight across is 55 degrees. Well, we learned on the front side that vertical angles are always congruent. So because this angle here is 55 degrees, angle 6 must also be 55 degrees. Okay, next we're supposed to find the measure of angle 1. Angle 1 is here, and let's see if we can figure out what the measure of angle 1 would be. Well, let's go back up to this picture at the top and notice again in this picture at the top we had two lines that appeared parallel, and every acute angle was congruent to the other acute angles. Every obtuse angle was congruent to the other obtuse angles. Well, number 1 here, this appears to be an acute angle, and an acute angle in this situation, when you have two parallel lines cut by a transversal, all the acute angles will be congruent to each other. So this angle, angle 1, will be congruent to all of the other acute angles. And in this diagram, that would be angle 3, angle 6, and then the angle that measures 55 degrees. These are all the acute angles in this diagram. So that means that angle 1 has the same angle measure as angle 6 and this angle, which was 55 degrees. Okay, and then last, we're supposed to find the measure of angle 2. Angle 2 is here. We don't have any other angle measures that are congruent to angle 2 that we can use. We know angle 2 is congruent to angle 4, which is congruent to angle 5, which is congruent to angle 7, but we don't know any of the measures of those angles. But what we do know is angle 1 measures 55 degrees. We figured that out in example 5 here. And we also know, again, from this paragraph above, that an acute angle and an obtuse angle in this situation are going to be supplementary to each other. That means they're going to add up to be 180 degrees. So the measure of angle 2 is going to be 180 degrees minus the measure of angle 1, which is 55 degrees. And so that means that the measure of angle 2, if we do some subtraction there, would have to be 125 degrees. And again, that's because angle 2 plus angle 1 have to add up to 180 degrees. Okay, and that makes sense looking at the diagram because angles 1 and 2 together form a straight angle. Straight angles always measure 180 degrees. All right, so lots of new vocabulary in this video, a little bit new information. If you had any questions, make sure you have those written down for the next time you're in class. And until then, have a nice day. You're all wonderful people.